Programming again today. Warning up front, they're still doing testing with the these here. So they'll be going off from time to time. I'm going to do my best to mute any pop-ups, but we'll just see what we can do here. But I'm gonna be tackling again the idea of I wonder if I can let's see here. This one I want to make the scratch buffer. Yeah. Let's see if I can make this maybe. Let's see here. Well, whatever. Okay. Note. There we go. Maybe if I try to leave this on screen, maybe people can see it from time to time and kind of know what's up in case things going a little haywire in terms of noise. We'll see. Hopefully things don't go too crazy. I think it'll be fine though. I think we can work with these things because I still want to attempt to deliver a bit of a stream, so we'll see what I can do. And I've got a hotkey. So there we go. That was the first little round of it. I'm pretty sure they're almost done. So what they had to do for the day was, oh, let me just double check here for a moment that my stream window is actually going to respond. But yeah, what they're doing, they're just going from the top floor down to the bottom. They have to go into every room and check that the alarm systems are functional in the rooms. So they flip on the alarm briefly, and it's loud enough that I've got little earplugs to handle the alarm, so we're making it work. Let me see here. Okay. Right, so today. Oh boy, let's see. Let's see here. Just fiddling around with my windows here, sorry about that. Gotta try and make everything work for me, not against me. Okay, we got something here. Alright, it looks like we're okay, and mute. Unmute, unmute. Okay. All right, so today, yesterday I spent a bit of time sort of giving a rough explanation for the data structure here. Boy, oh boy. I hope they're almost done. That's okay. So I was working on explaining the data structure that I'm using to create and store the 3D models. And today what I thought would be kind of nice is to build just a little helper function that can help me render out basically a point cloud of the functional representation, which looks like this. If I take frep of a 3D file here, it's just a singular function. And if I run that function, it expects one argument, and that argument is a point in 3D space. And if I pass that in, it gives me a scalar value, or it gives me a scalar value, so not a vector. It just gives me a distance. If it's negative, it's inside the shape. If it's positive, it is outside the shape. So with that logic, what I can do is, so if I had a theoretically maximally capable computer, I could sample an infinite set of space in 3D, right? Or infinite. I could sample a volume of 3D space from 0 to 1,000 in each direction, say, and then for each of those volume points, and for each of those volume points, for every step value in each axis, you could just run the functional representation function and get the distance, and then you just check if it's greater than 0 or 0 or greater than or equal to 0. No, that's actually wrong. If you do less than or equal to 0, then you know it's inside the shape, and you draw, you color that pixel, you color that space in. So enough, let me just try and implement it and see if I can come up with something remotely helpful. So what I'll do, what I could do, first thing I'm going to do, the first thing I'm going to do is make if I go up here and I do this, geometry, if I do some math and geometry stuff here, what I want to make is a function that calculates the bounding box, the bounding volume, I guess, of a shape that you pass in. And that actually can be pretty easy, if I recall correctly. It'll just be similar to, I have a function somewhere already that, here, bounding box. This works in 2 dimensions. So let me copy it over here and do it in, let's make it more generic, and so it works in n dimensions. It's just a day for me to sort of check my patience a little bit, you know. That's just going to be fine. I think I won't stream for too long today because this has got me a little off my best, but that's okay. We'll, you know what? We just take it in stride. We do one little step at a time, right? Okay, so what I want to do here is, instead of do bounding box center, what I actually want to do is produce a bounding volume, which is basically just going to be, if it's axis aligned bounding volume, let's just make this bounding box. I only need the bottom, like I need the minimum corner and the maximum corner. So for all vectors in a set of things, I could do, or vectors, vertices, sorry, right? I wonder if I could do some weird thing here. I don't know if this will work. Sort by first. That's guaranteed to give me the minimum of x. If I separately do, oops, second, oh, I could actually, this might be kind of easy here. Let's see. Oop. Let's get rid of this. Some shape. If I go here and I do let x's, right, be is this how I want to do this? Let's call it that. I think that should be fine, at least for now. So what I can do, let x's be sort by, oh boy, first, I'll make it generic if I do nth, or more generic, maybe. I don't know if that's actually better or not, but we'll see. Let's see if that even works. I think it will. Sort by nth 1, for example. Yes, it does. Okay. So what I can do there, and now I have the lists just sorted by, for each axis, the min and max of that axis, or by the from minimum to maximum. So what I can do in every case is build, if all I want to do is return the minimum corner and the maximum corner, I can just return a list that contains each point, and each point is going to be what's the right way to do this? Right, so what I'm doing here actually is something a little weird looking. I don't know if it's actually smart or not, but I'll see if it works and then I'll explain what's going on here. I'm sorting by the X values from minimum to maximum, and then for all of those points I'm taking just the first value, so I get just the X values of every point, and then all I need is the first and last from that. So here it'll be first X's, and then I do a similar approach, nth one for this, and likewise for Z's. Should be okay. Yeah, so first Y's, first Z's, Z's, and then here last X's, last Y's, last Z's. And we'll see if this makes actual sense in just a moment. Okay, so if I look at the vertices of A, does this first point make sense? -10 in the X is in fact here, right? Let's not be silly here. Let's make a okay, so let's build a few more functions around this idea here. So let's now do so we got the bounding box corners. Let's do produce a bounding volume of a shape. Okay, so what's going to happen here is we're going to let the BBC, no, corners. What's the smart way to do this? What I want to do is take the corner values and use those to sorry to anyone watching who's tuned in right now. The fire alarm stuff in my apartment is still being tested today. So I'm doing my best to kind of mute things before the alarm gets too crazy loud on the stream. But if you're watching and wondering if there's annoying noises going on, that's unfortunately the result of fire tests. I'm making it work. I'm doing the best I can, but sorry about any weird noises. I'm doing my best. But thanks for tuning in anyway. I appreciate it. I'm getting very reflexive, just quick mute, but it might not be fast enough all the time. So, apologies. They're going floor by floor, room by room, and running the alarm very briefly for each room. So it doesn't go on for very long, but it goes on very frequently. So it's not a perfect scenario. That's okay though. I still wanted to stream. I still want to get myself back in the groove, you know? I like doing it, so it's good to keep doing it. Okay, so what I'm going to do here is I'm going to run the function bounding box corners on the shape. So it gives me the corners, and this bounding volume function, I want to return a shape as well that just directly encloses that shape. So in order to do that, what I think I want to do is what do I want to do? I'm thinking. I'm thinking I might want to just do create the 4 corner points on the bottom face and just extrude it up to the Z point of the topmost corner, because that will produce the volume that I'm looking for. Just trying to think if that's actually the right kind of approach. And I think it could be. So how I'll do that is what I'm trying to think through right now. So what I can do is go kind of crazy with it. Let's see if this works, just for fun. So what I'm going to do is make C1 is an edge, and it's going to be the edge from the bottommost corner, not to the topmost corner, but to the along the x-axis. So what that'll be is what's a clever way to do this? Let's do A and C are those 2 points, and let's define B as first of C with, oh wait, sorry, I have to do it this way, into vector That one was confusing to me. It didn't make any noise, but oh. None of these alarms make sense to me. always forget how conj works. If I do conj like this, can't do that, of course, right? If I conj onto a regular list, I get something that goes to the front of the list. If this were a vector, it would put it at the end. So this here, I can do conj rest of A with first of C, put that all into a vector, and I get the B point, which is weird, but all this is doing is giving me the Y and Z values of the first point, which is actually not correct. Let me just change it. Let me change how I do this. It's a little more explicit, but it will also be a little clearer. So I need the Z point from, or I need the X coordinate from point C. I need the Y coordinate. Wait, was I correct the first time? This shouldn't be this hard. I was correct the first time. Okay. Yeah, so point B is the same as point A. The only difference is that instead of being the minimum X value, it's the maximum X value. So it draws a line along the one bottom edge of the bounding box. That's the whole goal here. So then C1 is curve 1, edge 1, I guess you could say, and it's going to be brep line, not line, from point A to B. Surface 1 is going to be brep curve extrude of I realize I need one more point. I need C to be the lights are flashing, but there's no noise anymore. Not sure what that's about, but I won't complain about it. Okay, C is going to be, so C, instead of going along the X, it has to go along the Y. So this one I'm going to make kind of manually here. It's going to be first of A, second of D, and this, by the way, has to change now to D because it changed this to D there. This should be good. And this one has to be last of A, and that's point C. So brep curve extrude is a function that I wrote. I don't remember. It takes some curve and some height. The flaw. The flaw in my current approach. I haven't actually written rotation transforms yet, which means this surface extrusion will only extrude along Z. It won't extrude along the axis I actually want it to extrude along. Which is a mistake that I've made in my assumptions. So, to handle that, I suppose it is probably time to make a proper rotate and translate and stuff like that. My hesitation is I'm feeling lazy, which is not great. So let's see. Is there a better thing to do? Well, let's get rid of this for the time being. Another lazy part of me came up with a slightly different way to do this for now. So what I can do here is let corners be bounding box corners of shape. That's good. And here, points, I'm just going to manually build the points that I need. And it's going to be messy, but it's going to be okay. Instead of calling it corners, we're going to call it point A and max corner, no, M, no, Z, because it's just some other corner. So I just need to produce corner B, corner C, and corner D. That strobe freaks me out still, but there's no noise anymore, I guess. Okay. Right, so all I'm doing here, right, I'm constructing the bottom face as just a polygon, and then I'm just going to extrude the polygon up to Z. So, in fact, actually, Z, it's a kind of a bad name, but it's good for now. This, let's call it bounding volume proto. Proto is like just a little call out to myself that, hey, this probably needs a bit of work, so it'll be fine for now. So point B is going to be first from Z, second from A, last from A. And in fact, all of these are going to follow the first, second, last scenario. So let's copy those. And the only thing that'll change is the point that they're drawn from. So, so I don't confuse myself, I'm going to just track this for a moment here with handy classic pen and paper. So we have A being the minimum in every case. B, I want to be positive X, positive Y is there, positive Z is there. Just this is all I'm doing, drawing out little helpers. Nothing wrong with using classical methods. Classical methods. This is not proper math. I'm just using a pen and paper, that's all I mean. Nothing wrong with it though. Okay. So A is computed for us already. B has the positive from Z, and everything else is the same. C should also have first from Z, second from the Z point as well. But the last point should still be from A because it's still flat there. This should be true as well. The only difference here is that should be first A, second Z. And so that should be all 4 points that make the square, well, the box that is the bottom face. So with those points, I should be able to do brep. I don't even need to do brep. I can actually just do polygon, right? Polygon just takes a list of points, which in this case can just be A, B, C, D. Then all I want to do is return the extrude of, I have to call this something, of course, extrude P1 to a height, and the height is just going to be the maximum Z value, which is last from Z, and that should give me a bounding volume. So let's try for the shape A, which is an extruded hexagon. I should be able to run bounding volume on that and get a new shape, which is the basically the box that perfectly encloses it. So let's see if it actually will work. Okay, it does give me something. I only have 4 vertices here, which is incorrect. No, that's not true. I should have 8 vertices here. So if I def B, let me make a new, let's go back here. Let's call this bounding volume B. So if I do vertices of B, count vertices of B, I should get 8, and I do. The reason I get 8 is because there's 4 vertices on the bottom. You extrude that square up, and now you've got 8 vertices total because there's another face on the top. And then all the other faces just join it all together. So the total number of surfaces should theoretically be 1, 2, 3, 4, 5, 6. I might have 7 because of a current sort of weird choice I made with implementation, but let's check. I should expect to see 6 or 7. And I see 7, and the reason for that is because as I extrude each edge, let me try to explain that a little differently. If I count the edges of polygon, and I do regular polygon points, radius 1 and 4, so this, the number of edges of this, I'm drawing a diamond, which is just a square. You would think the number of edges of just a polygon that is a square would be 4, but this should be 5 0. Oh, what did I missed something up here. Oh, I said edges and it's curves. Anyway, the point is here 1, 2, 3, 4, 5 curves. The reason there are 5 is because each edge segment is its own curve function, but I also have the entire curve set as a compound, as a polyline added to that list. I don't know that I need to, but I did, and that's why I get extra faces. While I'm thinking about that, maybe I should just maybe I should just get rid of that. Let's go to primitives here. Triangle. So the number of curves of a triangle I have here, B-rep line is fine. Here, this curve polygon here is that extra it's that extra thing I'm that extra curve function I'm adding. So this, I actually don't know what the right thing to do is. So let me put a little comment to myself here. I'll leave it in for now, because the alternative approach here is, instead of making, like, I only put in the combined thing, not each of the individual edges, because it should still work. I don't know what the right thing to do there is, so it's something to work on. But what I need to do here actually is kill this and redo this. And while that is going, because I made a new function and it has to pull that new function into the running app, so I just restarted the app. But while that's going, I'm gonna go to the washroom for a minute, so I will be right back. Something went wrong, which is theoretically fine, but I have to figure that out. Well, okay, I'll be back in just a moment. those tests they're frustrating me just a little bit, but that is okay. They'll be done soon enough, and I'm still managing a stream, which I think is pretty nice. So okay, so you know what, I don't need this I don't need that there. I just need to make a decision on that later to see. Basically, I don't know if it's more useful to have all curve segments independent, like each with their own function, or if it makes more sense to union them together into a chain and then have that represented as a single function of its own. I think probably keeping them separate is actually more useful. So doing this, just getting rid of that curved polygon there, I wonder if that's actually better. And likewise, when I do the regular polygon call here, just entirely removing this here, brep curve polygon points. So then I just do this map, you make a line for every line between those things. Uncertain about that right now, but for the time being, that is okay. The other thing I just recognized is actually it's actually not sufficient for right now I'm running a bounding box check on just the vertices of a shape that I pass in, but currently I've only implemented polygons and straight curves and stuff like that, so this will never happen. But it's totally possible that I have a set of vertices that are used at the end points of a curve, but the curve itself is not a straight line, and so the vertices might incorrectly indicate the bounds. Like there might be a curve that's some kind of sine wave based thing, and the two endpoints might be sort of they might trace out a midline of that curve, not in fact its minimum or maximum. So this bounding box thing that I have here won't be good enough unless I automatically include extra vertices in the vertices list for extents of each curve. Or I would recursively run bounding box on every curve element, every surface element, to get a set of min-max points for those, and then run the bounding box volume on those points. So it might have to be a two-stage thing. So it's all possible. It's just this isn't a complete implementation. But for the sake of checking that it even makes sense, I'm going to go over here and try to draw the bounding volume of this shape, because at least as a starting point that might work. So let's even check the logic of the version that I have now. Okay. I don't need it in mount, I need it in here. Okay. So if I do, so test shape here is the shape definition. Test bounding volume can just be / bounding volume. That is what I called it, right? Bounding volume proto, of course, of test shape. Now test BV should work just fine in this function here. . okay, something's wrong here, and this comes from, okay, probably the polygon function is defined later in the, yes it is, it's further in the file, so I have to declare it here. I would have to do this, declare polygon. This is one thing that kind of comes out as a bit of an issue sometimes with my approach here. I have a kind of loose, literate programming style where the idea is I can write code and write documentation and notes to myself all in the same file, and I can reorder things. And that usually works really nicely, but sometimes I end up writing a function and then later on I'm adding new functionality, but it's in a section that's earlier on in the file. And so what ends up happening is function definition order in the REPL and in the document end up not matching with what the document expects itself to have, and it can get a little confusing, that's all. So this looks correct now that it's rendered it out, but what I want to do is get both of them in here, so I'm just gonna do the lazy man thing and just do a test bounding volume is there and test shape is here. The bounding volume, I want to give it a different color here. Let's just give it pink. Okay, that looks pretty great actually. Yep, so that looks pretty much exactly correct. So as a starting point, that's not too bad. Right, so the reason I wanted to make a bounding volume thing is to help me limit the sampling of the functional representation, like the extents of sampling the 3D space. So what I mean by that is basically this is not an FREP remapper, it's actually a BREP remapper. Where's a good spot to do this? Let's see. We'll just go ahead and tack it on here. I'm not sure that that's a good name for it, but we'll go with it for now because it's the only thing I can think of. Voxel grid. How do I want to do this? I need to give it bounding box and steps, right? Where steps is X steps, Y steps, Z steps. And bounding box is min corner, max corner. I'm not sure about that signature, but we'll go with it for now because I can change it around later. And I just am building out a rough prototype anyway, so proto it is. Proto. Okay, so this function is just going to return a list of points that work like this. For x range the range of x is from first of min corner to first of max corner with a step size of x step. Then then for all, or then for y and z, it's the same kind of approach. Where y is second, y step, z step, and z is last from those. Okay, so for all of those, just do x, y, z, and that'll give me a big long list, right? So if I evaluate that, and if I take bounding box corners of A, it gives me 2 points to work with, which is min corner and max corner. Then if I want the step size to be 0.1, say, right? Or just 1, let's run that. Rep voxel grid proto with bounding box corners and a step size of 1 for each. It should give me, oh, of course I messed up my own signature there. Right, so that's a long list. But could be fine, potentially. So let's go with that. Voxel grid proto. So that'll actually just give me a whole list of points. Then what I need to do to make the functional representation render of that, I need to do that on the app prototype side here, which I shall do in a moment, but I need to think about that for a second. Okay, so test shape has some shape. Here, if I do test voxels, if I define that to be f/frep voxel grid proto of f/ bounding box corners of the shape test shape, and the step size is going to be 1, 1, 1. Test voxel points is that. Those are 3D points not transformed yet. Then what needs to happen there is def this is test voxels, and this now is this is where things get a little bit more complicated, right? Where I need to filter by way of running a check where less than or equal to the function the frep function of test shape is less than or for every one of those points is less than or equal to 0. And if you filter, you filter using this function, this check, all the points from voxel points. That gives me a subset of those points in that volume that are inside the shape. And then now here, test voxels, I can run this d/orient isometric on that. So, oh man, this is confusing me, but that's okay. I can work through it more clearly at some other point. This is just to make sure things will work at all, if I'm even thinking in the right way. I think I am. I just have to make sure it will actually work. Okay, so there we go. Test voxels now. This d/orient iso basically just takes a set of 3D points, rotates it so that it looks isometric, and projects it on by removing the z values. So it actually will be two-dimensional from the perspective of the SVG, but it'll look isometric. So that's all that this orient iso is doing. That's something I need to improve. I need to improve that by making some kind of proper scene and camera setup so that I can render SVG a little more intuitively. Because this is not that ergonomic an approach, and it's also not that extensible, so it could obviously use some improvement. But this should all work. I believe so. Okay, so those are all the test voxels I have here for, let's just repurpose this, for point in test voxels, render for me a red circle. Let's go ahead and see if this works. Oh, it actually won't, because I have to recompile. Maybe I don't have to recompile. Maybe I just have to refresh. I wonder. Okay, let's recompile, because it doesn't appear to be working the way I want, which should be fine. So let's sit back and relax for a second and see what happens here. You can see in here I'm just searching, poking around, trying to figure out different algorithms for different sorts of things, like, well, it's not working. Well, that's okay. I can have a look at this in just a minute. Let's get to a point where it's working, so we get a render. Voxel grid proto doesn't work, okay? Did I not tangle this? I might have not saved it. Shoot. Let's see if now it works. That's my bad. Let's try one more time. Round 2. What was I saying? Oh yeah, this, I'm just trying to figure out what kind of papers are out there. I don't know if I'm smart enough to understand them all, at least not on the first read through. But hey, we'll see. What's wrong with this? Really? Did I do the same problem? Did I make the same mistake? Bounding box, corners. Ah, of course, I actually did make a mistake here. Declare extrude. So that's not good, but this is still rendering, so I should be able to still... Let's see if this actually does something for me. Exception. Collections must be same size. Filter. I wrote something incorrectly here. Okay, so I have something wrong with my filter, and that would be what is it? What's wrong with this? Well, okay, let's take this into here and have a look. Okay, if I make voxel points, right, as the frep voxel grid proto of bounding box corners of shape A with the step size of let's do 2, 2, 2 to make it just even smaller. Okay, that's some set of points. Okay, it's not too long, which is good. Now, if I filter that set of points with, oh, pardon me, this, will it actually work? frep of A less than or equal to 0. That's the filter I want to apply to the set voxel points. Okay, so it works in theory. If I count this, 871, and if I count voxel points, okay, so there is, see this, it is in fact filtering a bunch of points out. There's still a lot of points, but it is filtering them. Why is that not working on this set of points here? What did I do? Okay, I don't know why that's happening. Okay, if I undo this, if I don't orient it, does that work? It does. Okay. So it's doing something wrong. Okay, there's a whole whack of points there, but it's doing something wrong. Interesting. What I can do, I think, well, let's not try to get too crazy with it. Let's see. see if that changes it. I don't think that'll fix it. Oh, it did. Weird. Okay. So what we have there is a very rushed implementation of a bounding volume render. Now what's I'm thinking what would be kind of cool is to make the color of the circle dependent on the distance value of the point, because that would give some, like, that would actually give color, so you could kind of see the edges of it without the edge function being in the way. The other obvious problem is it's over 1,000 points for a pretty simple volume, right? So it's not very robust. It's gonna slow way down. Right, so it's not perfect, right? Like if I bring these down, we're gonna drastically increase the number of points it has to put on screen, and it slows things way down right away. Like it renders them all, but that's a ton of points, and there's technically a lot of points that are behind one another, so they're technically useless to draw more on screen than necessary. But that is the volume. That is an sort of voxelized render of the functional representation of that shape, which is pretty cool, if I do say so myself. So I'm just thinking what might be kind of a cool thing to do. I don't know. So this is different than the surfaces I was rendering the other day, because this is all the whole actual 3D volume of the shape itself contained inside that exact shape. And this bounding volume, like this red line out here is the bounding box of the shape, but these points don't go, like, they're fully contained not in the bounding box but in the volume of this particular shape here, which I think is pretty cool, and it should look pretty regular too. If I change this from 8 to only 3, it'll be like an extruded triangle, and the function will still work, right? Now all of the circles are contained within that extruded triangle, and if I change the extrusion height, it should work just the same. Right now I also have the voxels, like there will be more, I'm using the word voxels a little bit loosely here, but they are kind of voxels. The bigger the extents of the shape I'm working on, the more voxels appear, and so technically the more render time it's going to take. So there's a few things that aren't, like, I'm not handling the cases of this in the most intelligent way across the board, but it's a good start. What else can I do? Have a call. Oh, today's been a hectic day. I have to go soon, probably 10 minutes. No, I'm gonna give myself 13 minutes or so I end up streaming for about an hour and a half total. I have to go do some last minute errands, unfortunately, but hey, that's the way it goes. Still managed to get a stream in, which I'm happy about, so I shall take that as a win. In the meantime, what is a good thing to do? I kind of wonder, actually, if I should test. I have to see what functional representation equations I actually have here, as I don't remember. I don't think I have a lot of them yet. I do have FREP union, difference, and intersection, which might be kind of fun to test. See if I can. Let's see if I can come up with a kind of hack together test for the FREP difference of two things. Let's try that. Okay, in order to do that, I can, so I'm going to make this 6, and the radius here is going to be 10. See how that looks. It's going to take a while, I guess, but there we go. Thinking. Yeah, okay, so that's good. That's test shape 1. Test shape 2 is going to be f/extrude, f/polygon, f regular, polygon points. It's going to have a radius of only 5. But it's also going to have 6 edges, and that's the polygon. And it's going to be extruded also by a height of exactly 6. So that's the second test shape. And the test bounding volume I can leave as test shape, that's fine. The voxel points, yes, it has to be fine. But here, test voxels, I'm actually going to make a new FREP, and that is going to be f/FREP difference. And that's going to take 2 functions. The first, I forget which order it's going to be. Max of A and B. No, pardon me. Well, we'll call test FREP. We'll do FREP test shape, FREP test shape 2. That's the test function. And so here, instead of doing this test shape FREP, we just run test FREP here. If we wait patiently, what I expect is that there's a smaller hexagonal hole inside this. If the difference function is worked as intended, There is, but it's hard to see. Let me do myself a small favor here. Let's change the extrusion height of this to just 2. This is 8, and this is 7. Yes, okay, so this is working the way I want it to now. So the all these circles here are indicating the volume of this test functional representation here. It is the difference, as in, basically what happened is test shape is the bigger hexagon. Test shape 2 is a smaller hexagon sitting inside it. And the difference is take away, like you negate all of the space that overlaps between both of them. So test shape 2, if I make it bigger, it'll just completely erase the whole bounding volume. So that's really handy in terms of the functional representation. It's really easy to have these operations here. But the next important thing I need is a way to make the wireframe model of it also work and have the face renderers and everything, which is much more complicated. So that's not necessarily easy, but that's part of the challenge, part of the fun. Right, so now that I made the inner radius of the hexagon in there smaller, right, the hole inside there shrinks, which is exactly what I was going for. Now this, just if I make this 24 and I make this say 32, this should have a high enough resolution that it kind of looks like a cylinder, and it could almost look like a tube, which it would be pretty great. See, and this is already a big problem, right? Rendering the functional representation with just a whole bunch of circles slows the browser way down, and that's not good. So we can't rely on it alone. I need to come up with a smarter render approach. So actually, while I'm thinking about that, there is minimal ray tracer. Basically what I probably need to do is have kind of two things. One is a ray tracer that uses like the WebGL canvas, and one is the SVG line work. And what I could do is theoretically one-to-one, I could have a canvas and then an SVG with alpha like laid right over top, and then I could get a reasonably efficient, nice colored sort of hybrid thing that I can maybe even have it do rotation and stuff like that, but that I have to think about. So let's see if this has any beautiful pictures, because this might be a good thing to implement next. Might be kind of fun to do. Donate thing. Okay, I've been on this. Scratch a pixel. Okay, I've been on this before. This is a very, very useful. This is a great resource, actually. Author, not sure who, but minimal ray tracer rendering spheres. Yeah, this is a good way to go. Yeah, maybe. See, that's pretty cool. Parametric implicit surfaces. This is speaking my language here, kinda. I have to think about how I want to implement this, but it's very obvious that this is not the smart way to do functional representation surface rendering, because it creates way too much SVG data and slows your browser rate down. Not good, not helpful, and not even that, it's not even that readable. Like, I can't even understand that exactly. So there's work to be done, but I'm okay with that. So thanks for tuning in, anyone who's watching live. I appreciate that. It was a strange stream, started a little late and had some noise related problems due to fire alarm testing. Apologies for that. If you're watching this on YouTube later, again, apologies for that. Anyone seeing this at any point, if you're wondering if you want to help me out in any way, how you could do that, you can check my Patreon. I want to build that up over time. It'll help me keep things going nicely, and it'll help improve my presentation ability, my hardware and stuff like that, and things can actually get a little better, a little more helpful, a little more formal on my part, and hopefully educational and useful and entertaining on your part. So you can help me with that. If you can't or don't want to do things through Patreon, you can also share this around through forums to your friends, things like that. All that kind of stuff would be extremely helpful, as would engagement on the VODs channel. You can subscribe, you can leave comments there. You can follow me on this channel. You can subscribe when I have reached enough status so that you can do that. And yeah, just share it around and engage. I would love that. And I'll be back again on Thursday. It's fun to get back into this. I'm really happy I did. And I can promise, maybe I can't promise it, but I really hope, and I don't expect that there will be fire alarm problems on Thursday or Friday or at any other point in the near future. So no worries about that. Okay, that's enough chit chat from me. I am going to call this stream good for the day. I did a few nice things. I got the rough bounding box idea in place. I have a somewhat usable functional representation viewer sort of thing, and I have a bit of an idea where I want to go in terms of work tomorrow. So that's great. I feel good about today despite all the weirdness. All right, have a good one. Thanks for tuning in. Please feel free to tune in again. Always engage in the chat if you want to. I'd love that. Blah blah blah. Have a nice day. I'll see you around.